Hi, today we're going to talk about the applications and interpretations of SL May 2021 Time Zone 1, Paper 1. So let's go ahead and start answering number 1. Katia approximates pi correct to 4 decimal places by using the following expression. The first thing that they want us to do is to calculate this approximation of pi correct to 4 decimal places. So they're telling us that our estimate for pi is here. So, we want to round to 4 decimal places. So all I have to do is put that in my calculator. So I'm going to have 3 plus 1 divided by 6 plus 13 over 6, 16. So when I get that, I end up getting that we have 343 over 109. Right? So when I do that, I want to round to 4 decimal places. So I can go to math, go down to decimal, press enter and press enter again. So to 4 decimal places, this would be approximately 3.1468 to 4 decimal places. All right. Next for part B. Part B says that we want to calculate the percentage error in using Catia's 4 decimal place approximation of pi compared to the exact value of pi in your calculator. So remember that the absolute value formula is you have the absolute value of your approximate or your estimate, subtract your exact form divided by the exact, and you have to multiply by 100. So I'm going to type it in exactly how it looks. And as you can see here, when I multiply by 100, I end up getting that my absolute value is going to be equal to, or my percentage error is going to be equal to 0.1658. Of course, we're going to put percent because it's in percentage form. All right. Number 2, it says, Deb used the thermometer to record the maximum daily temperature over 10 consecutive days. Her results in degrees Celsius are shown below. So the first thing they want us to do is they want us to find the mode. The mode is the data set that appears the most. So we see here that 14 appears 3 times. So my mode is 14. Part B, it says, what is the mean or the average? So if we want to find the average, we know that we can add all these numbers up and divide by how many numbers we have, or we can just run our stat diagnostics. So I'm going to go to stat, edit. I'm going to type in all these values into L1, and then I'm going to press stat, go over to calc, one variable statistics. My list is in L1, my frequency list. I don't have a frequency list, so I just go to calculate. And as you can see here, remember the mean is the X bar. So the mean is approximately 13.1. And actually, I can say it's actually not approximate, it's equal to 13.1. All right, your standard deviation, remember, is going to be the Greek symbol sigma, the lowercase version. So standard deviation is going to be approximately 2.21. All right, so that's number 2. Remember, we always use the sigma, not the SX, we don't use the regular S. That's the sample. We want the whole population standard deviation, which is the lowercase Greek symbol sigma. So number 3, it says a piece of candy is made in the shape of a solid hemisphere. The radius of the hemisphere is 6 millimeters. Calculate the total surface area of one piece of candy. So here we have a piece of candy that's a hemisphere. So in order to figure out the total surface area, we would have to find the surface area of a sphere first and then divide it by 2. But you will have to understand that that will only give you the curved part of it, and we will still have to find the area of the base, which is a circle. So if we found the surface area of a sphere, we know that we will end up having 4 times pi times r, which is 6, squared. So if we were to put that in, we would have 4 pi times 6 squared here. So that will be the area of the sphere. So that's going to be approximately 452. So I should know that the area of a hemisphere was going to be half of that. So I could say about 452 divided by 2, which is approximately 226. Now, remember, that's only the curved surface. I need to find the area of the base. So I need to find the area of a circle here, and that's going to be equal to pi r squared. So all I have to do is substitute that into the calculator. So if I have pi r squared here, we will end up having approximately 113. So if I add my area together, I know that my area of my candy is going to be 226 plus 113, which would give me approximately 339. And that's going to be millimeters squared. So now part B, it says the total surface area of the candy is coated in chocolate. It is known that 1 gram of the chocolate covers an area of 240 millimeters squared. So if I have a total of 339 millimeters and I want to see how much weight my chocolate should be, I can just take 339 and divide it by 240. So when I do that, I end up getting approximately 1.41 in 3 sig feet. All right. And we know that this is going to be in grams. So let's look at number 4. Number 4 says that the price of gas at Leon's gas station is $1.50 per liter. If a customer buys a minimum of 10 liters, a discount of $5 is applied. This can be modeled by the following function, L, which gives the total cost when buying a minimum of 10 liters at Leon's gas station. It's going to tell us that this function here, which is L of x is equal to 1.50x minus 5, where x has to be greater than or equal to 10. They're telling you that x has to be the number of liters that the liters of gas that a customer is going to buy. So A, it says, find the total cost when buying 40 liters of gas at Leon's gas station. So in order to do that, all I have to do is substitute that value in. So I will have L of 40 is equal to 1.5 times 40 minus 5. So when I do 1.5 times 40 minus 5, I get 55. All right, and we already know that because we are talking about money, this is going to be $55 here. All right, so let's look at part B. So for part B, they want us to find the inverse of L of 70. So anytime you find the inverse, that just means you swap out your X and your Y values, or you switch them out. So what you could have done here is you could have done it the traditional way. You could have wrote your equation in the Y equals form, and then you could have swapped the X and the Y, and then you could have solved for Y, which would have been X plus 5 divided by 1.50Y. That's equal to Y. And then you should be able to substitute 70 in for X here. So 70 plus 5 divided by 1.5 is equal to Y. And actually I can say Y equals that. And when we simplify it, we will end up getting that we have 75 divided by 1.5, which is 50. Another way that you could have done it is you could have just done it by vocabulary. We already know that when we have a -1 as our exponent, that means inverse. So you could have literally looked at it and said, okay, well, if I want to find the inverse, and then I'm plugging in 70, normally 70 would be plugged in for X based on where it's located. But since we're doing the inverse, we will plug it in for Y, and then we will solve for that variable, okay? So there are two different ways that you could do it. So next it has the price of gas at Erica's gas station is $1.30 per liter. A customer must buy a minimum of 10 liters of gas. The total cost at Erica's gas station is cheaper than Leon's gas station when X is greater than K. They want us to find the minimum value of K. Okay, so for part C, it says Erica's price at the gas station is going to be $1.30 times the amount of liters she gets, and that should be less than Leon's price, which is $1.50 times X minus 5. So when I solve this equation, I am going to add 5 to both sides and also subtract $1.30 on both sides for the X. So here, if I add 5 to both sides, I'm going to end up getting 5 on the left side. And if I subtract $1.30 X on both sides, I'm going to end up getting 0.20X on the right. So now I'm going to divide 5 by 0.20, and I end up getting 25 is less than X, which we already know ends up being rewritten as X has to be greater than 25 here. So it says we want to find the minimum value of K that Erica's gas station is going to be cheaper than Leon's. And it says when X is greater than some number K. So when I go to Y equals, I'm going to type in the price for Erica's gas, which is $1.30 X. And then I'm going to do the same for Leon. So that's going to be $1.50 X minus 5. And then I'm going to go to the table. So when I go to the table here, I am trying to see when my numbers are the same, because I know when they're equal, I can then look above or below. So I can see here when X is 25, they are both the same, but I'm trying to figure out when Erica's is cheaper than Leon's, which means that the price in Erica's on the left side in the left hand column is going to be lower than the number in the right hand column. So if I look here, I see that the number that is in the left hand column, I see that I have 31.2, and then I have 31. And then as you can see here, if I go down, I have 33.8 for x is equal to 26. So I have 33.8, and then I have 34. So I can see that as long as the x value is greater than 25, because 25 is where they are the same. So as long as x is greater than that number, that means that Erica is going to end up having a cheaper amount to pay for the same amount of gas. All right, so in other words, here we can say that x was equal to 25. So number 5, it says the Voronoi diagram below shows 3 identical cell phone towers. Tower 1, 2, 3. A fourth cellular phone tower, Tower 4, is located in the shaded region. The dashed lines in the diagram below represent the edges in the Voronoi diagram. For the horizontal and vertical scales, each unit represents 1 kilometer. So it says Tim stands inside of the shaded region. Explain why Tim will receive the strongest signal from Tower 4. So if Tim is inside of that shaded region, and we know that Tower 4 is inside of that shaded region, we could easily say that Tim will receive the strongest signal for Tower 4 because every point in that region and I'm going to say in that shaded region, to be more specific, is closer to Tower 4. All right. So then it says Tower 2 has the coordinates of negative 9, 5. So what I'm going to do is I'm going to label it. So Tower 2 has the coordinates of negative 9, 5. And it says, and the edge connecting vertices A and B has an equation y is equal to 3. So the vertices connecting edge A and B is the equation y is equal to 3. So I know here, for this line, this will end up being y equals 3 here. So that's a horizontal line. So they're asking us to write down the coordinates of Tower 4. Well, you have to understand that the only line that is perpendicular to a horizontal line is a vertical line going up and down. So I know that Tower 4 has to be on that vertical line, and it's going to have to be the same distance away from the horizontal line as Tower 2. So here from Tower 2 to the y equals 3, that was a distance of 2 between them. Because I'm looking at the y values. I'm looking at 3 and 5, it's a distance of 2. So if I want to go 2 the other way, that means that I'm going to basically have to have a distance there of 2, which means if I'm at 3 and I go down 2 more, I'm going to now be at 1. So I could easily say that this is Tower 4, and Tower 4 is located at negative 9, 1 here. So negative 9, 1 will be my answer for B. All right, so now C, it says tower 1 has coordinates negative 13, 3. So I'm going to plug in negative 13, 3 on the picture. And then it says find the gradient of the edge of the Voronoi diagram between towers 1 and 2. Well, I should realize that when they say find the gradient of the edge of the Voronoi diagram, I should understand that they're telling me to find this gradient here. They want me to find that gradient. So I already know that that gradient should be the opposite reciprocal of the gradient between T1 and T2. So what I'm going to do here is I'm going to use T1 and T2 to find the slope. So I'm going to find the slope between T1 and T2, and that's going to be equal to us having 5 minus 3 divided by negative 9 minus negative 13. So we're going to have 5 subtract 3 divided by negative 9 minus negative 13, which is just plus 13. So that's going to end up being 2 over 4, which simplifies to 1/2. But we all should know that the edge or the perpendicular bisector that we need to draw has the opposite reciprocal slope. So that means that I'm going to have that my slope of my perpendicular line is going to be opposite reciprocals of 1 over 2, so it's going to be negative 2. So that's the slope of my edge there. All right, so now let's look at number 6. It says, Arian has geese on her farm. She claims that the mean weight of eggs from her black geese is less than the mean weight of eggs from her white geese. So it's saying that she recorded the weights of eggs in grams from a random selection of geese. The data is shown in the table. So it says, in order to test her claim, Arian performs a t-test at a 10% significance level, and it is assumed that the weights of the eggs are normally distributed and the samples have equal variances. So the first thing they said is, in words, they want you to state the null hypothesis for this test. So if we look at the beginning, it says that she claims, or she is going to predict, that the mean weight of the eggs from the black geese is less than the white geese. So the null hypothesis means that nothing is changing. We are assuming everything to be perfect and stay the same. So in that perfect world scenario, I would say that the means are equal. So we could easily say that the mean weight of eggs is the same for the black and white geese. All right. Part B, it says state the p-value. In order to state the p-value, we have to run a test. So we're going to go to stat, go to edit. We are going to clear out anything that may be in there. And then we're going to put in the black geese information into L1. And then we're going to put the white geese information into L2. So now that I have that, I'm going to do the same thing for the white geese. So that's going to be 135, 138, 144, 140, 136, 134. So now that I have that, I'm going to press stat, go over to test. And we are going to do a 2-sample t-test because I'm comparing 2 separate things, black geese and white geese. So I'm going to do a 2-sample t-test. I know that my list one came from L1, my other one came from L2. My alternative hypothesis is saying that she claims that the mean weight of the eggs from the black geese is less than the mean weight of the eggs for the white geese. So I already know that for the list 1 and list 2, I know that's set correctly. But for the alternative hypothesis, I should have mu sub 1 is less than mu sub 2 based off of the wording. And then here, we already know we always deal with full tests. All right, so when we go here, we just go to calculate and we go to enter. And for the p-value here, we end up seeing that the p-value is approximately 0.177. That is the p-value here that we can approximate. So now, if we look at part C is saying that we need to state whether the result of the test supports Arian's claim and justify your reasoning. So we see the p-value is 0.177. So that is going to be greater than 10% significant than the 10% significance level. So because it's greater than that, we can easily say that Arian's claim is not supported by the evidence, because anytime your p-value is greater than the significance level, we end up accepting the null hypothesis. All right. So, or excuse me, yes, because when the p is low, we reject the whole. So remember, if your p-value is lower than the significance level, you reject the null hypothesis. Which means you accept the alternative. If the p-value is greater than the significance level, you accept it or fail to reject the null hypothesis. So because my p-value is less than the significance level and I have shown the actual numbers here, I can easily say that because of this, we are going to fail to reject, the null hypothesis. And therefore, we already know that no, it is not supported by the evidence. All right. So now let's look at number 7. It says, Professor, we observe that students have difficulty remembering the information presented in his lectures. He modeled the percentage of information retained or kept, which is R, by the function R of t is equal to 100 e to the power of pt, where t has to be greater than or equal to 0. And t is also the number of days after the lecture. So it says he found that on day 1 after the lecture, the students have forgotten 50% of the information presented. So we want to find the value of P. So for part A, in order to find the value of P, we will have to understand that R represents the percentage of information retained. So if it says that after a day after the lecture, they have forgotten 50% of the information, that means that they retained 50% of the information. So my R of T would be 50, and that will be equal to 100 times e to the power of negative p times 1, because it says 1 day after the lecture. So when I do that, I will end up getting 50 is equal to 100 times e to the power of negative p, and I'm going to go to y equals, and I'm going to put that in. So 50 and then equals 100 times e to the power of negative x instead of p, and then I'm going to graph this. All right, so when I graph it, I see that I only see one graph and I want to see the intersection. So I need to zoom out or I need to adjust my window. I'm going to easily adjust my window because I see that when I went to y equals, I had y is equal to 50, which means that I have a horizontal line at 50 on the y-axis. So when I go there, I'm going to just type in 60 so it'll be clear for me to see. And as you can see, I see the line there. And I also see the intersection. So now I can press second trace, go to number 5, get as close to the intersection as possible. Then I'm going to press enter 3 times. So I end up getting here that P is approximately 0.693. So that is the value of P. So next, for part B, it says, use this model to find the percentage of information retained by his students 36 hours after Professor Wee's lecture. So remember, T is the number of days. So here for part B, I would know that 36 hours is equivalent to 1.5 days because 24 hours plus 12 hours. So now that we have 1.5 days, we can substitute it in. So we're going to have R of 1.5 is equal to 100 times e to the power of negative p, which is going to be negative 0.693 times 1.5. So once we do that, we are going to end up having 100 times e to the power of negative 0.693 times 1.5. And when we do that, we get that we have approximately 35.4% here. So now it says, based on this model, Professor Wee believes that his students will always retain some information from his lecture. So it says, part C, state a mathematical reason why Professor Wade might believe this. So the first thing that I'm going to do is I'm going to look at the graph. So when I substitute this into y1, I have 100 times e to the power of negative p. And we know that negative p is going to be negative 0.693. And then instead of t, we're going to put an x there. So what happens here is when I graph this, I want to see how it behaves. So as we can see here, the way it behaves is it has an asymptote. Remember, an asymptote means that it kind of levels out where it gets close to a number, but it doesn't touch. So for C, that is the mathematical reason there. So here we will have to say that because of the vertical asymptote, we already know that R of T will have to be greater than 0. It will not ever be equal to 0, but it will be greater than 0. It will just get very, very small. Or we could have said that R of T has a horizontal asymptote. Either or. And last but not least, for part D, it says write down one possible limitation of the domain model. So when we talk about the domain, we are talking about the time here. So one limitation of the domain, remember the domain is saying that t has to be greater than or equal to 0. The reason why we have a limitation for this domain is that if we say t has to be greater than or equal to 0, what we are saying is that time continues to increase. And we know that people do not live forever. People are going to die at some point. So time will not increase forever for a person. Another reason that you could put here is the fact that if we are looking at the time being greater than or equal to 0, let's say if the time is 0, I am basically saying that, and going back to what R means, remember R means that's the percentage of the information retained after a certain amount of days after the lecture. If I say R of 0, I'm basically saying the percentage of information retained after 0 days after learning. So basically 0 days after learning the lecture, that will be the very first day that you learn it, or once you have just learned the information. It is impossible for you to learn something the very first time you see it and retain everything about it. That makes no sense. Okay? You're going to have some type of gap. You're not going to fully understand or master a certain topic the very first time that you see it in the beginning. All right, so there are two limitations there. So let's move on to number 8. So number 8, it says that we have Charlie and Daniela. They each began a fitness program. On day 1, they both ran 500 meters. On each subsequent day, Charlie ran 100 meters more than the previous day, whereas Daniela increased her distance by 2% of the distance ran on the previous day. So for part A, they want us to calculate for Charlie how long he ran on the 20th day of his fitness program. So for A part I here, we could easily say that we are going to have our arithmetic sequence formula because we know that it's increasing the same amount each day. So I'm going to have u sub 20 is equal to u sub 1, which is 500, plus 20 minus 1 times 100. And if I put that into my calculator, 500 plus 19 times 100, I get 2,400 meters. All right, so part B, part A2, it's asking how far did Daniela run on her 20th day of the fitness program. So I'm going to have use of 20. And I know this is geometric because it says she wants to increase by 2%. So not only does she want 100%, but she wants an additional 2%. So that is going to be 1.02. So I'm going to have 500. And then I'm going to have times R, which is 1.02, to the power of 20 minus 1. So once I do that, and I know 20 minus 1 is 19, so that's going to be approximately 728 meters there. So for part B it says on day N of the fitness programs, Daniela runs more than Charlie for the first time. So what I'm going to do here is I'm going to put both of my equations in Y1. So for my arithmetic sequence one, or for Charlie, what I'm going to do is I'm going to put 500 plus x minus 1, because remember we want to find n, and that's going to be times 100. And then for Y2, we're going to put 500 times 1.02 to the power of x minus 1 there. And then we're going to look at the graph. All right, so what I'm going to do is I'm going to press zoom. I don't see enough, so I'm going to press zoom fit so I can fit it to the screen. And then I should be able to see where they cross. So when I do that, I press second trace and I go to intersection. and I press enter 3 times. So I can see here that when I do this intersection here, I get 1/500. And we already know that that should be an intersection because it already said on day one they both ran 500 meters. So that should tell you that they crossed somewhere else. So I'm going to zoom out so that I can try to see both intersections. All right, so when I did that, I ended up seeing that I see it's kind of curved a little bit. So instead of me zooming out again, I'm going to go to my window and I'm going to extend my X max. I'm going to extend it and I'm going to make it 500 just to be safe to see where it crosses. So I see that is going to cross somewhere up there. So I'm going to adjust my window again. And I'm going to make my Y maximum. I'm going to make it 8,000. And so it can be a little stretched out. My X max, I'm going to make it 250 just to see. All right. So now finally I should be able to zoom out one good time and I should see where it crosses. So I see where it crosses there. So now I'm going to find the intersection by pressing second trace number 5. I'm going to get as close as possible and press enter 3 times. And I end up getting that the value of n, where they are the same, is approximately 184. So now I'm going to go to my table. And instead of me scrolling all the way to 184, I'm going to press second table set. And I'm going to tell it to start me at 184. And then I'm going to go back to my table. So now I'm here. So it says on day N of the fitness programs, Daniela runs more than Charlie for the first time. So I can see that Charlie is in my Y1, Daniela is in my Y2. So I can see on day 184, Charlie ran 18,800 and Daniela ran 18,741. But as you can see on day 5, Charlie ran 18,900 meters and Daniela ran 19,116 meters. So it was on day 85. So I know that here n is equal to 185 here. All right. So now let's do number 9. So number 9 says a rectangular field ABC is such that AB is equal to 56 meters and BC is equal to 82 meters. Each is going to be measured correct to the nearest meter, and the angle at B is equal to 105 measured correct to the nearest 5 degrees. So it says calculate the maximum possible surface area. Calculate the maximum possible surface area. So we should already know anytime we say the word maximum, we are trying to get the max bounds. So I already know that anytime we are talking about measurements of accuracy, we can go up or down half of the lowest unit that you see. So if we look at the measurements for meters or the side lengths of the field from A to B and then B to C, we see that it's rounded to the ones position. So I can go up or down half of 1, which is 0.5 meters. So I already know to increase my area, I can increase my lengths here of my sides. So when instead of using 56, I'm going to use the upper bound of 56. So I know that 56, my maximum or my upper bound is going to end up being 56.5. And I know that when I have 82, that is going to be, the upper bound is going to be 82.5. So now what we have to decide is, if we're using those upper bounds for our side lengths, we have to figure out what angle that we need to use. Well, it says that angles are being measured correct to the nearest 5 degrees. So if I'm measuring my angle to the nearest 5 degrees every time, then that means that I can go up or down half of 5 degrees. Half of 5 degrees is 2.5 degrees. So I can either go down 2.5 or go up 2.5. So from here, I already recognize that my theta has to be from 102.5 to 107.5. Because remember, I can go up or down 2.5 degrees. Okay. So I don't know which one is going to give me my maximum. However, what I could easily do is I could find my area here. So from these two values here, I could easily say that the area of the field is going to be equal to 1/2 times 56.5 times 82.5, and then that's going to be times sine of some angle here. So because I know the formula for my area, I'm going to go to y equals and I'm going to type that in. So I have 0.5, which is 1/2, times 56.5 times 82.5 times the sine of x. I know that's the same as theta. And instead of looking at the graph, if you want to look at the graph, that's fine. But I'm going to look at the table. So remember, we have this important piece here that our angle has to be in between these values. So that's my domain. So I'm going to go to table settings, and I'm going to have it start me at 102.5 here. And then I'm going to go back to my table. So as you can see here, from 102.5 to 107.5, I see that my highest area between here will end up being 2,275, approximately that amount. And if we rounded that to 3 significant figures, we could say that our maximum area on that domain, or for that domain, is going to be approximately 2,280. And of course, we are going to be looking at meters squared here. So that will be our maximum area on that domain. So number 10, it says a game is played where 2 unbiased die are rolled, and the score of the game is going to be the greater of 2 numbers shown. If the 2 numbers are the same, then the score in the game is the number shown on one of the die. The diagram is shown below with the possible outcomes. It says let T be a random variable, the score in the game. They want us to complete the table to show the probability distribution of T. So the probability that you're going to get 1 point is if you roll a 1 and a 1. So that's only 1 out of 36 ways. All right. So the next one, we're going to have the probability that you're going to get a 2. The only way that you're going to get a 2 is if you roll a 2 and a 1, or a 1 and a 2, or you can roll a 2 and a 2. So that's going to be a 3 out of 36. The only way that you are going to get a 3 is if you roll a 3 and a 1, a 2 and a 3, a 3 and a 3, a 3 and a 2, a 3 and a 1. So that's going to be 5 out of 36. The only way that you're going to score a 4 is if you get a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4, or you can get a 1 and a 4, a 2 and a 4, and a 3 and a 4. So that's going to be 7 out of 36. And the pattern will continue for 5. So that's going to end up being a 5 and a 1, 2, 3, 4, and 5. And then you can get a 5 and a 1, 2, 3, and a 4. So that's going to end up being 9 out of 36. And we do the same thing for scoring a 6. So if you score a 6, you're going to have here 11 ways to do it. So there's going to be 11 out of 36 there. So I have filled in my probability distribution table. So it says find the probability that a player scores at least 3 in the game. So that means 3 or more. So the way that you can score 3 or more is that you can have the values for the 3, 4, the 5, and the 6 here. So all of these ways that are highlighted are ways that you can score 3 or higher. So if we know that there are 36 possibilities, I already know that 36 minus 4 is 32. So basically, I have 32 out of 36. So here will be 32 out of 36 here. That will be my probability. The next one, it says a player scores, what's the probability that a player is going to score a 6 given that they scored at least 3? So we already have the probability that they scored at least 3 because we got that from part 1 that we just did. So we should remember that in order to score at least 3, we had 32 out of 36 ways to score at least 3. Now the probability that you're going to score a 6 is going to be 11 out of 36. So basically, in order to find a conditional probability here, if I have it, I'm going to say the probability that a player scores a 6, given that they've scored greater than or equal to 3. What I'm basically saying here is that I need to take out of all the ways they can get greater than or equal to 3, that'll be 32 out of 36. But out of the 32 out of 36, the probability I'm going to score 6 is going to be 11 out of 36. So 11 of those ways. So if I were to put that in my calculator, all I would have to do is say 11 over 36. And then I will have to, and let me put it alpha y equals. So I have to do 11 out of 36, and then I will have to put in the denominator 32 out of 36. And as you can see here, I will end up getting approximately 0.34375. And of course, if I put this as a fraction, I will end up getting 11 over 2. Or 11 over 32, 11 over 32. That'll be your probability. You could put it as a decimal or you can put it as a fraction. That's totally up to you. If you want to put it as a percentage, that's fine as well. You will have about 34.4% if you are on the 3C feed. All right, so now for C, it says find the expected score. So remember, your expected score is the sum of all the x values times their probabilities. So if we did that, we're going to have 1 times 1 over 36. So we're going to have 1 times 1 over 36 plus 2 times 3 over 36 plus 3 times, the next one was 5 over 36 plus 4 times 7 out of 36 plus 5 times 9 out of 36 plus 6 times 11 out of 36. All right. So when we put that in our calculator, make sure you are being careful. So once we have all of our x values and their probabilities multiplied, we add them together, and we will end up getting that our expected score would have been approximately a 4.47 and 3 sig feet. All right. So now let's look at number 11. It says, if a shark is spotted near to Brighton Beach, a lifeguard will activate a siren to warn swimmers. It says the sound intensity I of the siren varies inversely with the square of the distance d from the siren where d is greater than 0. It is known that the distance of 1.5 meters from the siren, the sound intensity is going to be 4 watts per square meter. We need to show that the intensity level or the sound intensity is equal to 9 divided by the distance squared. So in order to do that, we should already know what inverse variation is. So anytime it says show that, they actually mean show from scratch. It doesn't mean work your way from the answer and work backwards or substituting in. You have to work at it from scratch. So if I say that here it says the sound intensity varies inversely with the square of the distance. So if I say that the sound intensity varies inversely with the square of the distance, I'm saying 1 over d squared. And I already know that I can write this as an equation. My equation will be I is equal to K divided by D squared. So now from this problem, I see that they have already said that there is a distance of 1.5 meters and the sound intensity is 4 watts per square meter. So what I'm going to do is I'm going to substitute those values in. So I'm going to have 4 is equal to K divided by 1.5 squared, and I'm going to multiply both sides by 1.5 squared. So 4 times 1.5 squared is actually equal to 9. So I know that 9 is equal to K, which tells me that my formula or my equation is going to be y is equal to 9 over d squared. So the work that I show for A is enough for my answer here. So now for part B, it says sketch the curve I on the axis below, clearly showing the point 1.54. So in order to do that, I'm going to use the graphing calculator to help me. So I'm going to have here, I have I or y is equal to 9 divided by, and I'm going to put x squared, even though it's d squared. So when I do that, I'm going to graph it. And I'm going to zoom 6 so it can zoom standard. And this is the graph that I get here. But what you have to understand here is you're talking about your distance and you're talking about your sound intensity. So you have to understand that distance cannot be negative. So we're not going to use the left side of the graph when we do this. So if you were to sketch this, one thing we should already know is that if we look at our table, we can see, and I'm going to go back and change my table start to 0. When we go to the table, we can automatically see that as we keep going up on the x-axis, our x values are getting closer and closer and closer and closer to 0. So if I wanted to graph this, what I would end up doing is I will end up having, and I'm going to go back to the table really quick. If I go backwards, you should see that if I end up going up and making my x value really small, you see I start getting an error here. So basically here I start off at the first point, 1, 9. And I know that as I approach 0, I get an error. So if I'm at 1, 9, I'm going to be somewhere like right around here. So one thing that I can say here is that I'm coming down and then I'm going to level out as I get here. So as I'm leveling out here, I already know that I can estimate where 1.54 is. 1.54 is going to be somewhere in here. So that's all I need to make sure that I label, 1.54. You really don't have to label anything else. So if you wanted to, you could have graphed it. You could have literally sketched your graph to look like what the calculator is on the right-hand side and just estimate where 1.54 will be, okay? And if you wanted to, you could clean this up a little bit and you could have made it like this and bring it down a little bit lower if you wanted to. And if you did so, since it's 1.54, it will look more realistic for it to be around here. All right. So that is how you sketch the curve. So now let's look at number 12. So number 12 says Ellis designs a gift box. The top of the gift box is in the shape of a right angled triangle, G, I, K. So if I go from G to I to K, I'm talking about this whole triangle here. So it says a rectangular section HIJL is inscribed inside this triangle. The links GH, JK, HL, and JLJ are P centimeters, Q centimeters, 8 centimeters, and 6 centimeters respectively. It says the area of the top of the gift box is 8 centimeters. Part A says find A in terms of P and Q. So the first thing that you should understand here is that if I want to find the area of the entire figure here, I could break it up into sections. So I have a rectangle and I have two triangles. So if I want to find the area of the rectangle, that's just 8 times 6. And if I want to find the area of the triangles, I just have to take the perpendicular legs, so that can be my base and my height. So I'm going to have 1/2 P times 8 here. And this one on the right is going to be 1/2 times Q times 6. That's going to be the area. So if I want to find my area in terms of P and Q, all I have to do is add all of those areas together. So for part A1, we already know that the area is adding all of those up together. So we would have had 1/2 times P times 8 plus 1/2 times Q times 6 plus 6 times 8. That would have given us A is equal to 4P plus 3Q plus 48. So the next part is saying that we need to show that A is also equal to 192 over Q plus 3Q plus 48. So one thing that we should understand here about these two triangles that are in these pictures, the two smaller ones, is that they are similar. which means that they are proportional to each other. So that means that if I have P divided by 8, that's going to be proportional to 6 divided by Q. Okay? So because I know that P divided by 8 is equal to 6 divided by Q, if I cross multiply, I will end up getting PQ is equal to 48, which means that if I want to rewrite A like this, I'm writing it in terms of Q, which means I need to solve it for P. So I already know that here that P is going to be equal to 48 divided by Q. So because in part 2, I want to show that A was actually equal to 192 over Q plus 3Q plus 48, instead of me writing A is equal to 4P, I could say A is equal to 4, and instead of times P, I could say 48 over Q. And then that will be plus 3Q plus 48. So I already know that 4 times 48 is going to give me 192. So I know that the area is also equal to 192 over Q plus 3 times Q plus 48. So I showed that information there. So now for part B, they want us to find the derivative. So if we want to find the derivative here for B, we want to find dA dQ. So dA dQ is going to be equal to, now remember, if you want to find dA dQ, you have to realize that you have to rewrite A. So for the purposes here, I'm going to move this down really quick. I can say that A is equal to 192 times Q to the negative 1 plus 3Q plus 48 here. So if I want to find my derivative, I will bring down negative 1 down. So that's going to be negative 192 times Q to the power negative 2 plus 3. And of course, we do not use negative exponents. So when I change it, it's going to be negative 192 over Q squared plus 3. So that is my derivative there for part B. So next it says Ellis wishes to find the value of Q that will minimize the area of the top of the gift box. Write down an equation that Ellis could solve for to find this value of U. So of Q. You should remember that anytime you have a maximum or minimum, that occurs at a stationary point, aka where the derivative is equal to 0. So if I want to find my minimum, I know I'm going to set my derivative equal to 0. So that's going to be negative 192 over Q squared plus 3 is equal to 0. That's what that equation is going to be. And this is for part C1. So for C2, it says, hence or otherwise find this value of Q. So if I set my derivative equal to 0 and I have negative 192 divided by x squared, and I'm going to let me put this in a fraction form so I can make sure that it's fine. So I'm going to have negative 192 divided by x squared here plus 3. And then what we're going to do is we're going to graph it. So I see that it cuts my x-axis twice. So I should already know and understand that I have two possible values here. Okay, so if I have two possible values, I'm trying to see where there is a minimum. So I'm trying to see what the lowest area would be. So when I have this equal to 0, I already know that based on this equation, I already know that from this equation here that Q has to be equal to -8 or Q has to be equal to +8. All right, so anytime we have a minimum, that means that we should be going from decreasing to increasing. In other words, for the graph of my derivative, I need to be going from negative to positive, which is on the right hand side. So I already know that if I were to press second trace and if I was to find that 0, I would go somewhere on the right hand side and press enter. And then I will go somewhere on the left hand side and press enter. And then I'm going to go on the right side of the x axis and press enter as well. So once I press enter again, so I see that my value that I'm going to use here is 8. So I know that my my minimum occurs at 8 centimeters. So my answer is going to be 8 here. So let's look at number 13. It says Sion hits golf balls into the air. Each time she hits a ball, she records theta, the angle at which the ball is launched into the air, and L, which is the horizontal distance in meters, which the ball travels from the point of contact to the first time it lands. The diagram below represents this information. So it says that Sion analyzes her results and she concludes that the derivative of her horizontal distance in respect to the angle at which the ball is launched is equal to negative 0.2 times theta plus 9, and it's only for the angle values or the angle measurements from 35 to 75 degrees. So part A says determine whether the graph L against theta is increasing or decreasing at theta is equal to 50. So our we're going to use our derivative formula, because remember, derivative means gradient or slope. So we're going to use that derivative formula or equation to substitute in 50 for theta. So here I'm going to have part A is going to be equal to, and here it says the derivative of L. So we're going to have the L d theta. That's going to be equal to negative 0.2 times 50, because it says 50 degrees, plus 9. So negative 0.2 times 50 plus 9 is equal to negative 1. So from there, we can already tell that this is decreasing. So then it says Sion observes that when the angle is 40 degrees, the ball will travel a horizontal distance of 205.5 meters. So it says find an expression for the function L of theta. So we have the derivative, and if we want to find L of theta, all you have to understand is that they want you to find the integral. So if I have L of theta here, this is going to be equal to the integral or the antiderivative, and I'm just straightening this up a little bit. So that's going to be equal to the integral of negative 0.2 theta plus 9 with, of course, respect to theta. So remember, when you find your integral, all you have to do is increase your exponent and then divide by the new exponent. So when I find it, I'm going to increase my exponent to 2 for the first term, and then I'm going to divide by 2. And then I have 9 theta to the power of 0, but it's going to become a theta to the power of 1 divided by 1. And of course, we need our constant of integration, which is plus c. So we're going to have L of theta is equal to negative 0.2 divided by 2, which is negative 0 or negative 0.1. Okay, so negative 0.1, and that's going to be theta squared plus 9 times theta plus c, because remember the derivative of any constant is 0, so it would disappear anyway. So remember it says in part B, it says Seon observes that when the angle is 40 degrees, the ball will travel a horizontal distance of 205.5 meters. Find an expression for the function L of theta. So basically what they're telling us is that my length or my horizontal distance is going to be 205.5, and that should be equal to negative 0.1 times 40 degrees squared plus 9 times 40 degrees plus c. So if I were to type this in, I would have negative 0.1 times 40 squared plus 9 times 40, and that will give me 200. So I will end up having 200 is equal to, or excuse me, 205.5 is equal to 200 plus c. And so when I subtract 200 from both sides, I will end up getting 5.5 is equal to c. So when I write my actual function, it's going to be L of theta is equal to negative 0.1 times theta squared plus 9 times theta plus 5.5. So that is my function here for L of theta. All right, so if you have any questions, please let me know, and I will be more than happy to assist you. Have a great day.